This is question 2 from the 2021 Maclaurin Olympiad. The question shows that there are 12 points on a triangle, and each pair of points is to be joined by 6 line segments that pass through the interior of the triangle. So it must be the interior, so it can't go on the triangle side. And they've given us an example, which is extremely generous in an Olympiad question, to kind of basically give us a massive hint. So I'm going to redraw the diagram. So we have 12 points. Like that, and I'm going to label each one of these points in a different letter. And I think it's quite obvious that the corners A, E, and I are restricted in the sense that they can only join to the opposite side. So in the case of I, it can only join to these 3, because if it didn't, then it would be passing on the side, which isn't allowed. So A can choose H, G, and F. I can choose B, C, and D. And E can choose J, K, and L. And in general, that means that for these 3 corners, there are 3 times 3 times 3 different ways of arranging that. So that's 27 ways to arrange the corners. And for the other points, so let's just make up a scenario. If I just copy my diagram onto here, I ended up copying the whole question, but if we just copy it here, if we say pick I to go to B, A to go to H, and E to go to J, then if we pick another point, K, for example, if we pick K, K has exactly 4 choices. So K can choose C, D, G, and F. So C, D, G, and F. And it clearly can't choose L, because that would mean that it wouldn't be passing through the interior. So let's just choose a random value that K can pick, and we'll say that's going to be C. Okay, so that means K had 4 choices. Now, if we pick another letter, let's say G. G has exactly 2 choices, namely D and L. It can't be F, because that would mean it will pass through the interior, which isn't allowed. So if we pick G, it can pick D or L, which is 2 choices. And so let's say it goes to D. That means there's only 2 pairs of one pair of point available, and that's L and F. So F must choose L. So that's one choice. And we just picked an arbitrary starting point after we picked the corners, and we just said it was K. But it doesn't actually matter, because we could have picked any letter. We could have picked D, we could have picked G, we could have picked F. The outcome would have still been the same. So after the corners, point has 4 choices. Next point has 2 choices. And then the final point has one choice. So if we do the corners, which is 3 times 3 times 3, and then the rest, which is 4 times 2 times 1, and we just times them together to get the total number of combinations. That's going to be 3 times 3 times 3, which is 27, times 4 times 2 times 1, which is 8, and that gives us a grand total of 216, which is our final answer.